Hi dear students, everybody, good evening. This is Basheer, Math faculty, and welcome to Infinity Learn by Sri Chaitanya. Right dear students, in this series of classes, we have been discussing previous year questions of JEE Main, and we are getting ready for JEE Main that is going to be conducted in the month of June 2022. Right dear students, in my previous classes I have been discussing about calculus part. We have done limits, continuity and differentiability, methods of differentiation, and in part of applications of derivative, in the last class we have discussed one of the applications of derivatives, that is related to monotonicity, right. In this session we are going to discuss, in continuation to applications of derivative, we will focus on maxima minima, right dear students. So let us start our session dear students. Maxima and minima, applications of derivative 2, right. The next, before that, the most important part is I can say dear students, it is about Infinity Learn JEE channel. Please do subscribe to our channel, right. Stay tuned to Infinity Learn so that you will get wonderful videos, right. The next, my dear students, maxima minima related previous questions we are going to discuss. Say, what is maxima minima? I will just brief you, in the sense I am not going to give the synopsis, do not worry, because I know that you are already aware of this topic. Just I will give you few important points or a couple of points which help you to follow the questions. Point number 1, friends, here maxima or minima means local maxima, local minima. For example, if you take a function whose graph is like this, I can say, suppose this is x axis. So here I can say, dear friends, suppose this point is A on x axis, I can say here this function is going to have local maxima. Local maxima in the sense, in the surroundings of A, this is taking maximum value, right. And here you see, suppose this is the point B, here this function is going to take local minima, okay dear students, because you see it is going to be minimum in the surroundings of B. Similarly here it will have local maxima, local minima, local maxima, local minima. One important point is, the local minima of a function need not be the minimum value of the function in the given interval. It need not be minimum value, that is very, very important point. Fine. Suppose the function is defined on a closed interval, say P to closed interval Q, okay. In that case, dear friends, we can talk about the maximum value of the function, which is called the global maxima. Hi Anurag, list of you are asking, Anurag Patnaik, you want list of most scoring topics. Definitely Anurag, definitely I will. I do not want to deviate from this. Shall I do one more special section for this maybe tomorrow? Is it fine? I will give a strategy when how to prepare these coming 15 days. Shall I plan that? Anurag Patnaik, is it fine, or you want now itself? Shall I, Anurag? So I must appreciate your interest, definitely. If you okay, fine. So let me take a little small deviation from the topic, as Anurag is asking the most important scoring topics in JEE Mains. So I can say, dear students, you see, first you go with mathematical reasoning, right, math logic, what we call mathematical reasoning, math logic. So from this you will almost surely get one question, and second I go to statistics, friends. Yes, so don't expect the question from statistics to be very easy. Sometimes he is giving little lengthy, but damn sure you can answer question from this. And third priority, I always go to 3D geometry, which is easy in fact and very important. Go to 3D geometry followed by vectors. If you are not thorough with vectors, no problem, you start today, you can work a couple of days. Synopsis points will also be a few and solve previous year questions. Vectors and 3D together, you may get 3 questions, dear students. Yes. Then the next one, I go to matrices. Don't worry about determinants. In matrices, system of equations related question you will definitely get, and from exclusive matrices like adjoint, inverse and properties, simplification, induction problems, you will get one more question. This is a beautiful combination, dear students, and so you just need to work at, I mean to say, just go through the synopsis point, take the important points and solve a set of good number of problems you can definitely attempt. After this, friends, I suggest to go with differential equations, which is almost an independent topic. If you are good enough with standard integration, it is enough. You can solve a question from differential equations. Hardly there will be 10 model questions, you can attempt that. Another easy and independent topic kind of is inverse trigonometric functions, ITF. Okay? Yeah. Yeah, Anurag, you are asking, the question is this sufficient to go with PYQ? In this stage I can say yes, because you are having 15 days time almost, but my suggestion is everybody first go through the synopsis thoroughly and recall all the important formulae, then you go to previous year questions. Almost now in previous questions most of the models are covered, and I mean to say, don't expect the same kind of question, but you can get with I mean different combinations of those questions you may get. So that is also fine, because you take any previous year questions book, you can find per chapter almost there are 100 questions. That is enough in this stage, no problem. Almost topic wise segregated. So previous year questions don't go like paper wise, go chapter wise. Chapter wise, in that chapter also certain subtopics are divided. You see, if you take 3D geometry, direction ratios wise, lines, planes, like that they are divided. Such a way you go and cover at least at least 30 to 40% of questions of previous years of each subtopic. Okay. Oh, is it, Anurag? That is nice, you are attending my sessions regularly, that is really wonderful, wonderful. I will guide you in the best way, don't worry, Anurag. So how are you feeling the classes? Are you able to follow, Anurag? That's really very happy for me. You are following my classes and accordingly you are preparing. Undoubtedly I will give you better. Yes, very good. So you are happy, so I am happy, right. Okay, so first focus on these. After this I suggest to go with another topic. You see, in differential equations, if you are good at little graphs, you can go with areas, and 9 I suggest to go with straight lines, then 10 circles, and I can also say 11. Sure, definitely, Anurag, I will, don't worry, definitely I will guide you, don't worry. And 11th one I can say conics, that is parabola, ellipse, hyperbola. If you are unable to do the total topic, what you need to do is equation you prepare, that is enough in this stage. Okay. So we will be doing this, right, Anurag? First you prepare these 10 topics, you are going to get, I can say, around 12 to 13 questions from these undoubtedly. So, which is 50 marks guarantee from these 10 to 11 topics, 50 marks guarantee almost, yes. However, the paper may be, you will get minimum 50 marks from these topics. So, you prepare these, and after you get confidence in this set of topics, then you go to other topics. If you could not complete 100% the other topics, you revise at least the important areas. You see, in math, the number of students who are scoring above 40 marks are just 30,000 across the country. Yes, 50 marks is a good one. Of course, you can improve the score from there. So, my suggestion is first go through these topics. Okay, Anurag and everybody, dear students. Yeah. So, let me come back to the topic. So, how to get the 10 models of DE chapter? I will give, don't worry. So, after these applications of derivative, one more session I have planned, that is tomorrow one more session is there for applications of derivative, followed by next Tuesday we are going to do on differential equations itself. I will explain the 10 models, don't worry. Okay, right, Anurag? Fine, that is good. Yeah, coming to the point. You see, at Maxima Minima, what you need to know is, dear students, you see, you might have understood what is local maximum, local minimum. Now, how to check whether a function is having local maximum or local minimum? There are many methods. One of the best methods is first derivative test. What is first derivative test? You know, you see, if there is a function which is differentiable, of course continuous and differentiable, suppose f dash of alpha is 0, at that point derivative is 0, and you can say suppose alpha here, beta here, left side, just left of this derivative negative, right of this derivative positive, means tangent slope negative to positive, the graph will be having like this, it will have local minimum. Whereas, suppose f dash of beta is also 0 and left side of beta derivative positive, right side of beta negative, means slope positive to negative, the graph will take this turn. So, I can say, dear students, here the function will have local. This is very, very important basic point, my dear students. Point number 1, first derivative test. What is this? You just see where the derivative is 0. At that point, you can just see, suppose alpha is that, left of it, right of it, you check the derivative. If it is negative to positive, graph will be like this, it will have local minima. Whereas, if it is changing from positive to negative, the graph will turn like this, it will have local maxima. Hope this point is clear. This is what we call, dear students, first derivative test. Whereas, there is second derivative test. Suppose if you are unable to observe this, you can also do one thing. Suppose at alpha first derivative is 0, then you just find second derivative. If the second derivative at alpha is positive, second derivative positive means f will have local minima, f will have local minima at x is equal to alpha. If second derivative at alpha is negative, it will have local maxima. This is the point, friends. Okay, this is second derivative test. Now, you may question, what if second derivative is also 0? In that case, second derivative test fails, then we can go to nth derivative test. For example, for a function, you see f dash of alpha, similarly f double dash of alpha, similarly f triple dash of alpha, and so on. Suppose f n minus 1th derivative at alpha is 0, but f nth derivative at alpha is not equal to 0, right. In this situation, What can you say about the maximum minimum nature? It depends on this n. So, if n is even, my dear friends, you can just treat like n as 2 in mind. Now, if this is positive, local minima, negative, local maxima. Suppose if n is odd, you treat like n is 1. So, first derivative positive increasing nature, negative decreasing nature. I think you got my point, friends. If n is positive, the graph is going to have local maxima. I mean, if n is even, the graph is going to have local maxima or local minima at alpha. It depends on negative or positive nature. Whereas, if n is odd, you just treat like 1. First derivative positive means it is local, I mean I can say increasing nature. First derivative negative means decreasing nature. Accordingly, you can comment here. So, friends, for this topic, these 3 points are almost enough to enter the problems. There is no much synopsis. Of course, there will be few we can cover in the problems, nothing to worry. These points are enough. Apart from this, my dear students, there are certain points called stationary points, critical points and points of inflection. So, in this stage I want to highlight only stationary points. Stationary points are those points where first derivative is 0. For example, if you take the graph sin x function, y is equal to sin x in the interval 0 to 2 pi. What are stationary points, friends? Stationary points in the sense sin x derivative is cos x, at what values cos x becomes 0? X in this interval, x can be pi by 2 as well as 3 pi by 2, right. So, stationary points are those points of the domain, those points where the first derivative becomes 0. These are called stationary points. Stationary points. Don't worry much, simply stationary points means first derivative 0, that is all, right. Next one is critical points. Critical points in the sense the points of the domain where derivative is 0 or does not exist. Let me repeat, critical points are the points of the domain where derivative is 0 or does not exist. For example, you see, you take f of x is equal to mod x, right. This function is x when x is positive, minus x when x is negative. This is very familiar to you. It is differentiable everywhere, but at x is equal to 0, it is not differentiable because left side derivative 1, right side derivative minus 1. So, I can say 0 as a critical point to this function, whereas f of x is equal to, let me take 1 by x. 1 by x derivative is minus 1 by x square. This can never be 0, but this is not defined when x is equal to 0. So, what are the critical points? Can I say that x is equal to 0 is a critical point of this? In fact, no, because 0 is anyhow not there in its domain, right. So, friends, 2 points. Stationary points are those points where the function's derivative becomes 0. Critical points are those points of the domain where I can say the derivative is either 0 or does not exist. Okay. Time being, I am suspending the concept of, you see, points of inflection because it is rarely given. Okay. Right. Next, friends, now with this synopsis we can enter the problems. You just see this question, dear friends. Yeah, what is this? If x is equal to 1 is a critical point of this function, then What can you say about these options? Okay, dear student, critical point he said means the point at x is equal to 1, the derivative must either be 0 or does not exist. But you see friends, it is a polynomial, a smooth and continuous curve, e power x, a smooth and continuous curve. So, their product will definitely be differentiable. Derivative does not exist, question will never arise here. So, we need to check with derivative equal to 0. Try to find derivative friends. F dash x means, you see, with your permission can I write here so that it will be more clear how to take the derivative, u into v, right. U is, this is 3x square plus ax minus 2 minus a derivative of v plus v into derivative of u is 6x plus a, am I correct? Which is nothing but friends, I can say e power x into 3x square plus a plus 6 into x minus 2 minus a. This is the derivative. You just see where derivative becomes 0. E power x will never be 0. This becomes 0 when x is equal to 1. So, you put x is equal to 1 here, you will get 3 plus a plus 6 minus 2 minus a, this sum must be 0, right. When this sum is 0, dear friends, I can say, you see, you have to get the value of, you see, x is equal to 1 is a critical point, in the sense you just see a plus 6 into x, okay, this is minus 2 minus a. Now, he is asking the critical point of this function, then what about the local maximum, local minimum? You need to find the value of a, right. So, dear students, you see, I have taken f of x, its derivative, u derivative of v plus v derivative of u. So, you are going to get e power x into 3x square plus a plus 6 into x minus 2 minus a plus a is also there. So, this gets cancelled friends. So, you will get only minus 2 here. So, a will be left. So, a you can take friends, this is going to be minus 7, right. When a is minus 7, what is f of x friends? Now, you can say 3x square plus, you can take like minus 7x, a is minus 7 minus 9 into e power x, okay. Now, this is the function you can talk about its derivative, right. X is equal to 1 minus 2 by 3. You need to compute the things properly and check where its derivative. You see, this is the function what we got, whose derivative is this. You can put directly derivative here itself, e power x into 3x square minus 7 means minus x minus 2, which is nothing but you can take like e power x into, you see, 1 is a factor, x minus 1, the other root is minus 2 by 3 means you can say 3x plus 2. Now, you see friend, the mechanism what I have applied in the synopsis, you take the number line, the derivative becomes 0 at minus 2 by 3 one number and other number is 1. Now, you just see friends, right side of 1, e power x anyhow positive, both the expressions are positive. So, by wavy curve method, this is negative, this is positive. So, friends, positive to negative means it will have local maxima. At 1, negative to positive means local minima. So, friends, I can say at x is equal to 1 local minima, at x is equal to minus 2 by 3 local maxima. So, option D is the right answer. Okay, friends. Let me brief the mechanism what I have done in this class. In this particular problem, f of x is given. To find a, I have used this data. Its derivative, I made it equal to 0 at x is equal to 1, I got a value. So, function is known. I want to check with the local minimum, local maximum nature of this particular function. So, what I do is, you see friends, derivative, this mechanism, you see where the derivative is going to be positive, negative, what we call it is first derivative test. Okay. I have done first derivative test, with the help of which I can close that. Option D is the right answer, that is at x is equal to 1 it will have local minima, minus 2 by 3 it will have local maxima. Okay, dear students. Next, you see the second question, you see determinant kind of it is given. Let small m and capital M respectively the minimum and maximum values of this determinant, fine. Then the ordered pair of small m, capital M. What you need to do is, you just apply operations, dear students, and try to simplify this. I think you can operate it as, with the help of R1 you just do R2 I change as R2 minus R1, so that little simplified version comes. Similarly, R3 also I change as R3 minus R1, right dear students. Continue. The first one cos square x will be like this itself. Second one 1 plus sin square x, let it be there. This is sin 2x, let it be there. Now, the next step R2 minus R1 you do, this becomes 1, this becomes minus 1, this becomes 0, right. I think you got my point. R2 minus R1 I have done. Now, R3 minus R1, this is 0, this is minus 1 and this is 1, this is the determinant. Now, it is not that difficult to expand this, you just expand it. So, you will get friends cos square x into, you can say minus 1 minus of 1 plus sin square x into, you can write 1 plus sin 2x is multiplied by, you can say minus 1. You just simplify this friends, this is matter of expanding this. Minus cos square x minus sin square x is minus 1 minus 1 minus 2 minus sin 2x friends. So, up to here it is a problem of determinants, right. I did not do anything related to maximum minimum, but I got a simple expression, standard expression where it is a linear trigonometric expression. Here when sin 2x maximum value, single expression is there, we can find the answer easily. When to the maximum extent, when this is 1, this becomes minus 3, when it is minus 1, this becomes minus 1. So, friends, I can say this expression's minimum value is minus 3, maximum value is minus 1. So, option B is the right answer. You see, namesake it is a problem related to maxima minima, but in fact it is a problem related to determinant. Here you just applied operations, right, fine. Shall we go to the next question friends? Yeah, you see this question, AD, BC be two vertical poles at A and B respectively on a horizontal ground. Okay. AD is 8, BC is 11, AB is 10 meters. Then the distance of the point M on AB from the point A such that MD square plus MC square is minimum. Okay, fine. From this data you can understand that, suppose this is the base AB, you can take the first pole is AD, second pole is I can say BC. Okay. Next dear students, AD is given as 8 meters, BC is given as 11 meters, okay, and this distance AB is also given as 10, fine. Now, the distance of the point M on AB from the point A, suppose M is here, I want this distance, in what way? MD square, this distance square, and MC square, this distance square is minimum. Friends, by Pythagoras theorems, if this is x, this is going to be 10 minus x. Fine. You just consider md square plus mc square. What is md square, dear friends? Which is 8 square plus x square. What is mc square? You see Pythagoras theorem, 11 square plus 10 minus x whole square, right? So now I can write 8 square plus 11 square is a constant, and this is the expression like x square plus 10 minus x whole square. Do not simplify. I want its minimum value. So let me check where the derivative becomes 0 first. Take its derivative, friends, 2x plus 10 minus x into 2, and 10 minus x derivative is minus 1. So this is the derivative of, if I take it as f of x, so this is f of x, friends, f dash x. You just see where derivative becomes 0. So x is equal to 10 minus x, when x is equal to 5 it is possible. I am not going to check with the second derivative because it is the only possibility. If at all you want, you can also check x is anyhow positive, the second derivative is going to be 4, which is greater than 0. So at x is equal to 5 it will have minimum value. So friends, when x is 5 means when this is m point is exactly midway between a and b, it is possible. So friends, I can say he is asking, read the question properly, the distance of the point m from AB is going to be 5, dear students. Okay, clear everybody, right? The next question, yeah, you see this is another question, the set of all real values of lambda for which the function f of x has exactly one maxima and exactly one minima in the interval when x is taken between minus pi by 2 to pi by 2. So what is f of x, friends? 1 minus cos square x is nothing but sin square x, of course, into lambda plus sin cube x. This is the function. I do not want to apply u into v kind of, so I have separated. So clearly you just take its derivative, friends. What do you get? Lambda sin square x derivative is 2 sin x derivative is cos x, plus sin cube x derivative is 3 sin square x into sin x derivative cos x, which is, friends, I can say you can take sin x into cos x common, fine, so that you will get 2 lambda plus 3 sin x. Okay. You just see, friends, where the first derivative becomes 0. I think you got my point. This is sin x into cos x into 2 lambda plus 3 sin x is the derivative, it is f dash x. Okay. You just see where derivative becomes 0, dear students. So in the interval minus pi by 2 to pi by 2 open, cos cannot be 0, sin becomes 0 when x is 0, whereas this becomes 0, 3 sin x, that is when sin x is equal to minus 2 lambda by 3, the derivative 0 is possible. If sin x is equal to 0, dear students, okay, what about the second derivative here, third derivative here, you can see. Now dear students, he is saying that, you see, if sin x is 0, in fact this total expression becomes f of x is equal to 0. If f of x is equal to 0 constant function, it will not have any local maxima or local minima. So this case you can discard. So sin x is equal to minus 2 lambda by 3 is such a one, should be such a lambda should be so chosen such that there must be one maxima and one minima, right. So friends, sin x, if lambda is positive, there will be one solution in minus pi by 2 to pi by 2, because sin function from minus pi by 2 to pi by 2 is a monotonic function. If lambda is negative also, there will be one function. So finally there exists one and only one number alpha such that sin alpha is equal to minus 2 lambda by 3. Okay. So friends, now you just take x values I can take from minus pi by 2 to pi by 2. Okay. 0 is one of the values where the function becomes 0, and suppose alpha is here. Actually alpha can be positive or negative. So, you can observe that the first derivative case, when alpha is, I can say, between 0 to pi by 2, the root more than this, you can observe the possibilities. You see the derivative is this, at sin x is equal to 0, the derivative becomes 0, and just right side of 0, sin positive, cos positive, this value depends, you will get like positive, negative, positive, negative, positive you will get. Even if alpha is this side also same nature comes, exactly you will get one local minima, one local maxima. So, I can say friends, this is all possible when minus 2 lambda by 3 lies between minus 1 to 1. So, clearly minus 1 less than or equal to minus 2 lambda by 3, not even 2 we have to get. I think you will not get equality. So, you just see it lies between, you just multiply with minus 3 by 2. So, 3 by 2 greater than lambda greater than minus 3 by 2. Whereas, if lambda is 0, sin x is 0 again, this function becomes 0, you can't find any local maxima, local minima. So, I can go with option D friends. So, lambda can be minus 3 by 2 to 3 by 2 other than 0. Okay, dear students. Find the next one. You see this question? The area of the largest rectangle ABCD whose vertices AB lie on x axis and vertices CD lie on the parabola y is equal to x square minus 1. Okay, below the x axis is. You see friends, what does it mean? This is the parabola y is equal to x square minus 1, right. So, I can take this parabola, this is the parabola, right. Yeah, fine. Suppose he is saying ABCD is a rectangle whose two vertices lie on x axis, CD lie on the parabola below the x axis. That means, suppose AB are taken here, you can take CD here. So, this is going to be the rectangle. So, suppose this length is x, dear friend, that means the point A is like x comma 0, this is going to be 2x, length of the rectangle is 2x, breadth, since this parabola is y is equal to x square minus 1, this length you can take like x square minus 1. Yes, this is going to be the area of the rectangle, which is to be, I have to find the maximum, largest rectangle he is asking. So, maximum value you have to take. So, the derivative you can take 2 into x cube minus x, find its derivative. This is f of x friends, its derivative f dash x is going to be 2 into 3x square minus 1. So, derivative becomes when x is plus or minus 1 by root 3. So, when x value is 1 by root 3, dear friend, that means 1 by root 3 comma 0, I can say it will have, and the area is going to be, you can substitute here. So, 2x, that is 1 by root 3 into 1 by 3 minus 1, right, it is minus 2 by 3, anyhow area we can put modulus minus 4 by 3 root 3. So, 4 by 3 root 3 is going to be the maximum area. So, derivative helps a lot to find. I am not checking whether it is going to have maximum or minimum, that is the only possibility we are going to have, that is all time waste to check all these things. Okay, dear students, fine. The next, you see this question, polynomials related questions are also being given very frequently, simple question these are. You see friends, f of x is a polynomial of degree 4 having critical points at minus 1, 0, 1. What does it mean? Critical points are those points where derivative is 0, right. So, I can say f of minus 1, f dash of minus 1 is 0, f dash of 0 is 0, f dash of 1 is also 0. Okay. T is a set of all x where f of x is f of 0, okay. Then the sum of the squares of all the elements of T. Fine, you see friends, from this f of x is a polynomial of degree 4 means its derivative will be polynomial of degree 3 whose 3 roots are known. Can't I take f dash x like say x minus 0 into x plus 1 into x minus 1 into k? Why not? So, because this is a cubic polynomial, maximum it will have 3 roots, k into kx into x square minus 1, or I can say k into x cube minus x is going to be f dash x. From this, dear student, can you say f of x? F of x is going to be its integral k into x power 4 by 4 minus x square by 2 plus c. This is going to be f of x. Now, f of 0 is going to be c itself, right. Now, you need to solve the equation. What is that equation, friends? F of x is equal to f of 0, that is k into x power 4 by 4 minus x square by 2 plus c is equal to c, which means x power 4 by 4 minus x square by 2 is 0. So, that is x power 4 minus 2x square is 0. So, you can say x you will have 0 0, x is plus or minus root 2 you are going to get. So, x has 4 values here 0 0 root 2 minus root 2. Now, sum of the squares of all the elements, dear students, you can say here 2 plus 2 4 is the answer. That is all. What an easy problem. You just see, dear students. So, f of x is some polynomial whose derivative related 3 roots are given indirectly. You form f dash x, accordingly you find f of x, okay, right. Next question. You see another question of this kind, f of x be a polynomial of degree 3, oh, and f of minus 1 is 10 and f of 1 is minus 6, f of x has critical point at x is minus 1, f dash x has a critical point at x is equal to 1, then f of x has a local minimum at what value of x? Dear students, you just see f of x be a polynomial of degree 3, what is the data given? F of minus 1 is 10, okay, f of 1 is minus 6, fine, and has a critical point f of minus 1 means f dash of minus 1 is 0. Yeah, even f dash has a critical point at x is equal to 1 means f dash of 1 is also 0, because critical point means derivative must be either 0 or does not exist, whereas a polynomial is a smooth curve. So, does not exist case will not arise, fine. The next, f of x has local minimum at, you see when it is f of x is a cubic polynomial, its derivative is quadratic polynomial, right. Already its 2 roots are given. So, can I take f dash x as k into x square minus 1, because the 2 roots are x is equal to 1, x is equal to minus 1. So, f of x is going to be, friends, k into x square minus 1. In fact, dear students, I can say, yeah, f of x means need to integrate, yeah, k into x cube by 3 minus x plus c. Now, it is very easy, you just need to find k and c. For that, f of minus 1 is equal to 10 data is given, f of 1 is equal to minus 6 data is given. So, you just substitute, you will get 2 equations, you will get k value, c value. So, f of x is known completely. Now, f of x has local minimum at, you have a procedure, once you know f of x, local minimum is that point where its derivative is 0, 1 or minus 1. Now, local minimum means, friends, you can take the second derivative, that means second derivative is 2kx, right? F double dash of x is 2kx. So, if you want local minima, right, so this must be positive. Depends on k value what you are going to get. K you substitute at 1 and minus 1, that is f double dash of 1, f double dash of minus 1 you find. At those points you have to choose that where second derivative is positive, that is all. Okay, fine. Next friends, you see this question, yeah, f of x, I will give the brief idea of this. F of x be a polynomial of degree 5, fine, such that x is plus or minus 1 are its critical points, means f dash of minus 1 is 0, f dash of 1 is also 0, fine. And here some printing error is there, you please read it as, you see, limit x tends to 0, 2 plus f of x by x cube is equal to 4, this should be here. Limit x tends to 0, 2 plus f of x by x cube is equal to 4, right. Then which of the following is not true? Fine friends, you see f of x is a polynomial of degree 5. You see friends, if f of x is a polynomial having x square term or x term or constant term, when you divide with x cube, x will be retained in the denominator, the limit will become infinity or does not exist. But the answer is a finite number, so f of x must not contain x square term, x term, constant term, right. So, you can choose f of x like, dear friends, a x power 5 plus b x power 4 plus c x cube, that is all. It can't have further terms, otherwise this limit cannot be finite. Moreover, when you divide this with x cube, you just apply this limit, this with this by x cube means a x square plus b x plus c, you apply limit x tends to 0, it should be 4. Friends, that means you will get c value is equal to 2, yeah, c value is equal to 2. Once c is equal to 2, dear friends, I need a and b. Now, you can also see, you see, is the derivative. So, you can take now f of x as, you see, a x power 4 5 plus b x power 4 plus 2 x cube, you can feel. Now, its derivative you just see 5a x power 4 plus 4b x cube plus 6x square, where you can take x square common, 5a x square plus 4bx plus 6 you are left with. You see, it clearly it is x square means 0 is one root and it is quadratic, already you got the roots of this are 1 minus 1. So, it must be like x square minus 1, x square plus minus 1. So, since it is 6, 5a must be, you see, minus 6, then and b must be 0, then only this becomes x square minus 1, so that you will get plus or minus 1 2 roots, dear friends. Okay. So, I can say b value is 0, a is minus 6 by 5, therefore, I can say f of x is minus 6 by 5 x power 5 plus c value is 2x cube. This is our polynomial. Once polynomial is found, it is not that difficult to find, right friends. So, he said f of x is odd, yes, it is an odd function. 1 second. Here he has given not true. Not true in the sense you have to choose the wrong option, right. So, generally if you don't read this question properly, you will go with first option because f is odd function, but in fact not true. You can check a, b, c, all the 3 will be correct options. X is equal to 1 is a point of minima, x is equal to minus 1 is a point of maxima. first derivative test will help you like anything here, dear students. Okay. Fine. Next, you see this question, dear students. Yeah, m is the minimum value of k for which the function f of x is increasing in the interval 0 to 3. And at the same function, to find the minimum, why do not you take this x inside, because x is anyhow positive, k x cube minus x power 4 is the function. So, m is the minimum value of k for which this function is increasing in 0 to 3. Increasing means first derivative positive, right. So, first derivative you just take, if this inner one is increasing, automatically the total function is increasing. So, this is k into 3x square minus 4x cube must be positive. You can take x square common, 3k minus 4x must be positive. X square is anyhow non-negative. In this interval you leave about 0, it is positive. So, 3k minus 4x must be positive. So, 3k is greater than 4x, or 3k by 4 is greater than x. Yes, whereas friends, x is taken in the interval, I mean to say 0 to 3, that means x belongs to this interval. 3k by 4 must be greater than every number in this. So, 3k by 4 must be greater than even 3 also, right. So, k is greater than 4, dear friends. So, that means k value should be greater than 4. The minimum possible value of k is going to be 4, which is m. So, m must be 4. Option C and D are ruled out, dear students. Now, in the rest of the things he is asking, capital M is the maximum value of this function in the interval 0 to 3 when k is m. That means choose k value as 4. Now, it is 4x cube minus x power 4, dear friends. Can't you find its maximum value? Same, you just find the derivative, you just see where the derivative is 0. So, you can say k is already 4 you have given, right. So, x must be 0, you will get k is equal to 4 means x must be 3. Again you go with either second derivative or first derivative test, you will find that, but x is equal to 0, it is going to be minimum, x is equal to 3 is the case where you will get maximum value. Substitute here, k is equal to 4, x is equal to 3. If you take 27 common, 3 root 3 will be the answer. So, answer is going to be B option. Okay, dear students. In the same way, yeah, you see this is another, most of the questions you can apply with this logic. Here you see A1, A2, A3 and so on are in AP, given A6 is equal to 2, the common difference of the AP, okay, which maximizes the product A1, A4, A5. You see A1 into A4 into A5, this product is to be maximized. Given A6 is already 2, suppose friends this is A1, A2, A3, A4, A5, A6. I want this product to be maximized. He has already given this as 2, but these numbers are in AP. A5 will become 2 minus D, 2 minus 2D, 2 minus 3D, 2 minus like this. You see A4 will become 2 minus 2D and 2 minus 3D, 2 minus 4D, this is 2 minus 5D, right. I have to choose D such that product of these 3 numbers is maximum, not a big issue. You see, you take the function f of D like 2 minus 5D into 2 minus 2D into 2 minus D. This is a cubic polynomial in D, f of D it is. You just see where the derivative becomes 0, apply first derivative test. Just only thing you need to do is you decode the problem into our language, prepare the function in terms of D, then derivative test, that is all. So, in the same way friends, these are all the same kind of questions, polynomial where the derivative, this function will have local minimum, local maximum. So, first derivative test helpful to you. Okay. You see, you will also get problems related to geometry, like the height of the right circular cylinder of maximum volume inscribed in a sphere of radius 3. That means, sphere is fixed whose radius is 3, dear students. Now, there can be many cylinders inscribed in it, many cylinders. Inscribed means the edges will be touching like this. Many cylinders can be inscribed. What could be the height of a right circular cylinder of maximum volume which can be inscribed in this? You see, volume of a cylinder formula is pi r square h, where r is going to be the base radius of the cylinder, height is going to be vertical height. Fine. If this is the height, friends, pi r square h, this part is going to be h by 2, which is going to be radius of the sphere, which is 3. Now, friends, we want to maximize the height, right? We want the height when volume is maximum. So, we want, you see, in terms of height, not radius, you can write here h square by 4 plus r square is equal to 9. So, volume you try to write like pi into h, r square you can replace by 9 minus h square by 4, which is, friends, pi into 9h minus h cube by 4. This is the function. You need to maximize this. So, take the derivative with respect to h, pi into 9h derivative is 9 minus 1 by 4 into 3h square. So, you just see where derivative becomes 0, friends, h square is going to be 12, h is going to be root 12, dear friends. Yeah, 2 root 3. Yes, this is the answer. Like this, even geometry problems also can also be converted easily. You just see what is to be maximized or minimized, I mean to say optimized, prepare the function for that and see that it should be in terms of h, which is the parameter you require. So, now I have converted derivative, make it equal to 0, see the case where it is maximum or minimum, right, dear students. In the same way, here even trigonometric are also incorporated, and all these are polynomials related, I mean geometry related, even coordinate geometry related questions, parabola already we have done some questions, these are numbers related, this is polynomials exclusively kind of, not polynomial, algebraic kind of. You see, again this is polynomial oriented question, it is geometry oriented question, like this, dear students. So, I want to say, my dear students, here Maxima Minima is a topic in which synopsis part will be only a little, hardly you will be doing 2-3 points. If you could do some 20-30 problems, you can catch the rhythm, how he is giving the problems, what to approach. Definitely you can easily solve the problem related to Maxima Minima in the exam, because anyhow we are practicing derivatives, right, dear students. That is all. And before that, yeah, join our Telegram channel Infinity Learn by Sri Chaitanya for further updates, right, dear students. Yeah, Infinity Learn by Sri Chaitanya is your best mentor, right, dear students. And tomorrow we are going to meet to discuss applications of derivative class 3, yeah, okay, where we will be discussing mean value theorems related problems, right. See you, take care, bye bye.